In the world of multimedia, everything starts with data. For example, sound, visuals, movement, all are stored, processed, and delivered using complex systems. But before we dive into the technical part, we need to understand the basics of analog and digital signals. Let's start with analog signals. These are continuous waveforms that change smoothly over time. Unlike digital signals, which are made of discrete steps, analog signals can take on an infinite number of values. Imagine drawing a line. With analog, you can move your pencil in one smooth, continuous motion, like drawing a curve. But with digital, it's like drawing with building blocks or stairs. You can only place blocks at specific heights and positions. While analog signals can have any value, like measuring temperature to infinite decimal places, for example, 36.34567889 degrees Celsius, digital signals must round to specific values, like rounding to whole numbers, for example, 36 degrees C, 37 degrees C, 38 degrees C, and so on. This is what we mean by discrete steps versus infinite values. Think of an old thermometer with mercury. As the temperature changes, the mercury level rises or falls smoothly and continuously. There are no sudden jumps or steps. This smooth, unbroken movement represents an analog signal. Analog signals represent data in a continuous flow. They don't break into steps or chunks. This continuous nature makes them perfect for capturing real-world data like sound and light. They can have any amplitude or frequency within a range. This means they can record the tiniest detail. Analog signals are vulnerable. Over time, external interference, wear and tear, and even copying can distort the signal. That's why cassette tapes get noisy and vinyl records develop scratches. You experience analog signals every day. Your voice is analog, so is natural light, or the gentle movement of a thermometer's mercury. Even traditional television and radio use analog transmission to broadcast content. So why some people still prefer analog signals? Analog captures the fine details. That's why photographers appreciate traditional film cameras. They capture subtle gradients and tones that digital can miss. Analog systems are often more straightforward and less complex to build. Think of how easy it is to tune an old FM radio. But still there are downsides, and that's where digital starts to shine. With every copy or playback, the quality drops, noise creeps in, and clarity fades. Analog data takes up a lot of space, and transferring it over distances without losing quality is tough. Editing analog data requires physical manipulation. You want to cut a scene? You literally have to cut the tape. There is no undo button. Today, most multimedia systems rely on digital signals, but everything starts with the analog. What we hear, see, and feel is analog by nature. The magic lies in converting these signals into digital form for better storage, editing, and sharing. Let's recap what we have learned about analog signals. They are continuous and smooth. They offer infinite values. They are great for natural sound and visuals, but they are also prone to noise, harder to store, and difficult to edit. Understanding analog signals is the first step to mastering multimedia systems. Up next, we'll explore digital signals, how they work, and why they have become the backbone of modern multimedia technology.